Hello everyone and welcome back. So by now you should be starting to work on your first project, the RAG Assistant project, and this lesson is going to act as a tutorial or a guidance on how you can start implementing this project, and hopefully it will help you overcome the mental block that some of you may have whenever they start thinking about the implementation. So feel free to skip this lesson if you feel like you want to do this from scratch on your own. That's completely fine. But this lesson is here to help you if you want to. So we have a code repository here that's going to act as our project, and you're going to see there are some methods in the code that are incomplete, like this one, and your job is going to be to complete these methods or implement the logic itself, but the structure of the code is there for you. So to start, first thing you need to do is to create an environment and install the requirements that you have here. And then don't forget to set up your environment variables. So I'm giving you an example here. You will need one of the API keys, either for OpenAI, Grok, or Google. Anyone is fine. You need just one of them. So these are the essential things. For the model names, that's optional. You can set an LLM name to work with, and if you don't do it, that's fine. The code's going to handle it for you. Same for the embedding model and collection name. You will need these things for your RAG system, but again, if you don't set them, the code is going to handle them for you. So at least just provide one API key. So after setting up your API keys, you will see that we have a data directory, and if you look inside, you'll find some text files with some content in there. And this is going to be the first thing that you'll need to do in your project, which is put your own data inside of this directory. And this is the text data that the RAG system will use. So for here, I'm giving you examples. Feel free to use them or replace them with your own data. And they can be anything. They can be .txt, PDFs, Word documents, whatever. That's fine. And after putting the data in here, the first thing that you'll need to do in your project is to read this data. So you need a method that reads whatever content in this directory, and it returns it as a list of strings. So that's what you have here in the app file. This is the first thing that you should be doing after putting the data in the directory, which is reading the data. And the logic here is going to depend on what kind of data you have here. For example, if you have PDF files, then you'll probably use a package to read the PDFs for you, or if it's Word documents, you might use another package. If it's .txt, I think that's the most straightforward thing. So yeah, that's the first thing that you'll need to do. Now, after loading the documents, I recommend that you then go to the VectorDB file and start working from there first, just because VectorDB is a standalone class, and yeah, you should be able to start working from there because it doesn't depend on anything else. So if you look in here, you have the constructor of the class, and what it basically does is it creates a collection for you to store your data in a DB, and it instantiates an embedding model from Hugging Face, and it uses ChromaDB. Now, you are free to use ChromaDB or to use any other VectorDB. If you decide to go with ChromaDB, then you don't need to do anything here. It's already set up for you. If you decide to use Pinecone or Face or whatever, then you will need to modify this method to adapt for your DB selection. So let's assume you decide to go with ChromaDB. You don't need to do anything in this method. Then comes the chunk text method. So whenever you're working with RAG systems, you need to store large pieces of text, and for you to do this, you have to chunk it. Now, there are multiple options on how you can do chunking. So one option here is simple word-based splitting, which is basically splitting by spaces. You can do that. However, I don't recommend that you do it this way, basically because it's very manual, and it's the most basic thing that you can ever do. However, it is going to work fine It's not like it's going to break your system, but it's not the best option out there. Option 2 is to go with recursive chunking, which is kind of the default for chunking methods in a lot of scenarios. So you can, for example, use the recursive character splitter from LangChain, or you can do semantic splitting. And I'm not going to go into details on how it works, but LangChain also have a class. It has an object that performs semantic splitting, and basically it uses embedding models and computes similarity between different pieces of text to decide whether two paragraphs, for example, should belong to the same chunk or not. So feel free to explore these options, and your method's going to take in the text, and it should return a list of chunks. You're completely free to choose how you do it. So after you do this, you need to implement adding the documents to the database. So after chunking the text, you will get a list of strings. This list of strings is the input to adding the documents, and then you need to implement this based on which database you're going with. Finally, you need to implement the search functionality. So after your documents are in the DB, you might get a query. And when you get that query, what you should do is embed that query, convert it to an embedding using the same embedding model that you used to embed the documents here before inserting them in the DB. And then you perform the similarity search. You give that embedding to the DB and ask it to give you, for example, the top 5 results. And then you format these results and return it that way. So if you're working with ChromaDB, I forgot to mention that, if you're working with ChromaDB, whenever you're adding documents, it's going to ask you for an ID. So if you're adding a chunk, it's going to ask you for an ID. So each chunk should have an ID and an embedding. Okay, you can add metadata, that's optional, but at least if every chunk should have an ID and embedding. That's for ChromaDB, the ID part. If you're working with other DBs, you might not need an ID. So here I'm assuming that there are IDs and I'm returning them. And by completing these methods, you are done with the implementation of the vector DB. So when you're done working on your DB, you can now go to the app file, and you'll see it has a RAG assistant class. This is what we need to work on now. So this class in the constructor, it initializes an LLM. It initializes a DB, which is the class that you have already implemented. And what's missing here is the prompt template. You have to fill this on your own. So in each RAG system, there should be a prompt where you give instructions to your LLM. You give it the context retrieved from the vector DB, and you can inject the user input. So you should craft this template. It's a template where it has an instruction, a place for the context, and a place for the instruction. And yeah, if you look at the initialized LLM, this is done for you. You don't need to do anything here. Basically what it does is it checks the environment variables that you have here. And if you have an OpenAI key, it's going to use an OpenAI model. If you have a Grok key, it uses Grok. Otherwise, it uses Google. So this is set up for you. You don't need to do anything here. In the RAG system, there is a wrapper function that's called add documents, which is basically adds the documents to the DB, which is the method that you should have implemented here in the vector DB class. So again, nothing to do here. And yeah, finally, the invoke method. So whenever you are trying to use your RAG system after it's completely implemented, the user will provide an input, and your job is to take that input and search for the most relevant results using your vector DB and retrieve that context. And after that, you would need to inject the context into the prompt that we showed here. So inject the context here and also inject the user input, and you give that to an LLM. So basically you let the LLM answer the question based on the retrieved context, and you return the LLM answer. So after you're done implementing the invoke method, now you are ready to run the app.py file and see how your RAG system works. So for this, I'm going to switch to another project where I actually implemented the solution, and I'll show you how it looks like when you run it. So let's run this. So you can see we're using an OpenAI model, and it loaded 7 documents, which are the ones you have here. And now you can ask a question. So I will say, what is AI? So you can see it replies, artificial intelligence is a branch of computer science that aims to create intelligent machines, etc. So if you go and look at this file here, you'll see it has the same introduction. It's a branch of computer science, aims to create intelligent machines. So you can see it is retrieving the relative context based on the question, and the LLM is generating the answer. So you can see the RAG system is working correctly in this case. So that's it for this tutorial. I hope you found that useful. Feel free to work with this template, implement your solution directly into it, or use it to give you an idea on how your project can be structured. And feel free to start completely from scratch. Try different things in the template. For example, try different chunking methods, try different embedding models. There are a lot of things that you can try here. So give that a try, and I hope you found that useful, and I'll see you in the next tutorial.